And now we have completed all of the mathematics work necessary to answer this question. But the final step in any related rates question, because they're all word questions, is when they ask us in words, we answer in words. They said, find the rate at which the water level is rising when the water is 3 meters deep. So the water level is rising at a rate of 8 over 9 pi meters per minute. And there we go. There is our third related rates example. The one thing that I want you to carry away from this question is that you are going to be required to critically think and problem solve. You are going to have to figure out ways to come up with variables that are not overtly given to you in the stem of your problem. From geometry, we have multiple relationships we can count on. And the people that write my AP test love cones. They love cones, and here's why I think they do. There are 3 variables involved in the volume of a cone. You must use not only the chain rule to implicitly differentiate, but the product rule as well. Look how much calculus they get to test just by using a cone as opposed to a circle or as opposed to a sphere, something that just is one variable in terms of only one other variable. Cylinders and cones, the volume of those, show up on my AP test a lot. So make sure you understand these relationships. Let's work one additional example. Again, we'll go through the steps in the process for related rates. It is a very straightforward question, and it's one that I think would very easily show up as a multiple choice question. Not very time consuming, really straightforward, but one last final time I want you to see the steps in the process for answering a related rates question. Assume that oil spilled from a ruptured tanker spreads in a circular pattern whose radius increases at a constant rate of 2 feet per second. How fast is the area of the spill increasing when the radius of the spill is 60 feet? Steps 1 and 2. Draw a picture, glean all of the information from the stem of the problem that you possibly can. There's my picture. Oil spilled from a ruptured tanker spreads in a circular pattern whose radius increases at a constant rate of positive value 2 feet per second. How fast is the area of the spill increasing when the radius of the spill is 60 feet? Steps 1 and 2. Step 3, find an equation that relates the variables involved. All the variables involved here are area of a circle and radius of a circle. We remember from geometry, there's the equation we're dealing with. Step 4, implicitly differentiate with respect to time. Find an equation that relates the rates. There we are. Plug in any information that was given to you. They gave me R. They gave me dr dt. They said R was 60. They said dr dt was 2. R is 60 feet, by the way, and dr dt is feet per second. That is going to help me make sure that I come up with the correct units to the rate of change of area. This question is answered by the area of the spill is increasing at a rate of 240 pi feet squared per second. They ask me in words, I'm going to answer in words. The area is increasing at a rate of 240 pi feet squared per second. There are 4 examples of different types of related rate problems that you might encounter. This is the first concept that we come across that really challenges your ability to, number 1, model words using mathematics, and number 2, to critically think and problem solve your way through information that you're given toward information that you need. This is going to be, up until this point, the one most responsible concept for increasing your ACT math subscore. If you can do related rates at a level that we need to do them on our test, you are going to expand your math brain, and it is going to show up and translate into a higher math subscore on the ACT. Come to class next time and we'll work homework problems on related rates.